Hey guys, and welcome back to another video on the channel. In today's video we're going to be integrating this following integral. The integral from 0 to infinity of natural log of x on 1 plus x squared dx. Okay? We're going to be integrating this using Feynman's technique of integration, so pretty much setting it to a parameter and differentiating under the integral sign. If you want to have a go at this integral before the video, pretty much get started because I'm going to get straight into it straight away. So I'm just going to move this over here and we're going to define this function in terms of a parameter. So we're going to let f of alpha equal this integral here. So the integral from 0 to infinity, and I'm going to place the alpha in the logarithm. The reason why I'm going to do that is because when I differentiate it, I'm going to get pretty much a 1 over, that's a k, sorry, a 1 over alpha, which I can then take at the front of my integral. So alpha x on 1 plus x squared dx. So with this pretty much adding this parameter, this pretty much means this is f of 1. So when alpha is equal to 1. So this is just alpha. And now we're going to differentiate both sides with respect to alpha. So that means f dash of alpha is equal to just the derivative operator with respect to alpha of this following integral. Now what we can do here is we can bring inside this the operator inside the integral and turn it into a partial derivative. Pretty much the partial derivative treats the other variable as a constant, so the only thing we'll be differentiating with respect to will be alpha. So the rest of it is quite an easy differential. So change this to a partial derivative and we have natural log of alpha on x on 1 plus x squared dx. Now since it's a partial derivative, every bit of x is treated as a constant. So what we're really differentiating is just pretty much natural log of alpha x. So if you differentiate that, what you're going to get is just 1 over alpha. Because it doesn't matter what this is, it will cancel out if you apply the chain rule to this situation here. So what we get here is pretty much f dash of alpha is equal to the integral from 0 to infinity of pretty much 1 over alpha on 1 plus x squared dx. Now what we can do is, because this integral only depends on x, we can take this out the front and treat it as a constant because this bit doesn't have any x's, hence it's just a constant in terms of x. So we have f dash of alpha is equal to 1 on alpha and the integral from 0 to infinity of 1 on 1 plus x squared dx. Now we can see here this is quite an easy integral. This is just an arctan pretty much. So what we're going to have is f dash of alpha is equal to 1 over alpha arctan, or tan inverse of x, with the square brackets 0 to infinity plugging in your bounds. So what we're going to do is break this down, substituting in the infinity. So we'll have f dash of alpha is equal to 1 over alpha, and then you put in the infinity, so tan inverse of infinity, which we can't evaluate but we can get pretty close, minus tan inverse of 0. Right, so tan inverse of infinity is pi over 2, because if you look at the tan curve, it approaches, as it goes to infinity, it approaches pi on 2. So that means when you tan inverse infinity, you should get pi over 2 because of this asymptote here. So we're going to have f dash of alpha is equal to 1 on alpha pi over 2, and then tan inverse of 0 is 0, so what we have is just f dash of alpha is just pi on 2 times by 1 on alpha. Now what we're going to do is find f of alpha, so all we're going to do is integrate both sides with respect to alpha pretty much, so this will turn into f of alpha. Here we can treat the pi over 2 as a constant, bring out the front, and integrate 1 on alpha with respect to alpha. Of course this will turn into natural log of alpha, so we'll have pi on 2 natural log of alpha with a plus c as well. So now we have this situation here where this integral, this integral is equal to this expression here. So what we're going to have is pretty much the integral from 0 to infinity natural log of alpha x on 1 plus x squared dx is equal to pi on 2 natural log of alpha plus c. Now we want to find this plus c so we can evaluate this integral, so we're going to let alpha equal, well, we can't put in 0 because a lot of it will get messed up really easily. So what we're going to do is pretty much substitute in, we could kind of put in 0, because if we do put in 0, what this is going to turn into is, well, it's going to be undefined, but this side here will also be undefined. So technically your C is going to be 0 in this case here. But if we look at the log curve like this, as you go closer and closer to 0, you get negative infinity here, pretty much. So if you look at this curve here, as you get closer and closer, you approach negative infinity. So if you put alpha of 0 in a natural log, you can pretty much say it's negative infinity or undefined, but we can say it's negative infinity. Here we're also going to have a negative infinity as well. Now, if you put in that there, what we're going to have is pretty much, if I take this out of the way, if you put in alpha is 0, you can replace that with just pretty much log of 0 on 1 plus x squared dx, integral from 0 to infinity, is equal to pi on 2 log of 0 plus c. We can replace the log of 0 with negative infinity, and so with this, so we can take that negative infinity out the front. So minus infinity, integral from 0 to infinity of 1 on 1 plus x squared dx equals pi on 2 minus infinity plus c. And if you actually checked, this will turn into pi on 2 as well. So don't forget this is getting multiplied. So what we have is technically minus infinity times by pi on 2 is equal to pretty much negative infinity times pi on 2 plus c. So if this side equals that side, that means our c must be 0. So in our original equation up here, the integral from 0 to infinity of natural log of, what is it, alpha x on 1 plus x squared dx is going to be equal to pretty much pi on 2 natural log of alpha. Okay, so our original integral was when alpha equals 1, so you put in alpha equals 1 and we get this integral here. So the integral from 0 to infinity of natural log of x on 1 plus x squared dx equals pi on 2 times log of 1. Log of 1 is 0, so this is 0. The reason why it is like this is because if you actually look at the graph of our function, it's going to look something actually like this, where this entire region is equivalent to this entire region. Now you can actually graph that function there, and that's the reason why it's 0, because this area will cancel out with this infinite area here. But anyway, that's that integral done. Let me know if you have any questions in the comments, and I'll try my best to answer them. Thank you.